Welcome ladies and gentlemen, boys and girls. Today we are going to solve another school's problem, which is subtree of another tree. So basically the binary tree problem, and it's quite simple as well. So let's see what the question is saying. The question is saying, given two roots of the binary tree, which is root and subroot, and we have to return true if there is a subtree of the root with the same structure and node values of subroot and false otherwise. Okay, so this hell is saying, let's say we given this root and we have given us another subroot, and we have to check is this subroot present in that complete root. Okay, what I mean by saying this is, let's say we have given two boxes, a cupboard, let's just say, and this door is empty, so I have the empty drawer on the side as well. So I have to check whether it's getting fit inside or not. If it's getting fit inside, then I have to return true for that, and otherwise I have to return false for that. Okay, so I hope, ladies and gentlemen, the question is very clear. So let's see how we're gonna solve this problem for this one, ladies and gentlemen. So it's not a big deal to solve this problem. So what I'm gonna do is I'm thinking about, let's just say we will check some conditions. We will check some conditions. My first condition will be, I will see if my, let's say, root is null, then what I will do, I will simply return true or false for that, because if my root is null but I have subroot present, then I will return false for that. Okay, because that could not be possible. And my another condition will say okay, I will traverse this root completely, this root left and right. Okay, so that's what I'm saying. I will traverse its left first and then right first. Okay, and I will check is this subroot present on this left. If it is present, then I will return it. If it's not present, then I'll go for the right and I will check if it is present or not. Okay, ladies and gentlemen, so here's come one thing over here which I want to share with you, and the thing is, let me just scroll it down a bit. So this example to test case, this is a very interesting one, because by using that I will show you one condition over here. Okay, so what is saying, we have in this root and we have to find the subroot. Okay, so I will travel over here and I will see 412 is present. But ladies and gentlemen, remember we got some 0 over here, so this cannot be matched on this one. You will say no dude, the values are same. Okay, but in this one this 2 does not have any leaf node, but in this one it has a left leaf node. Okay, so we have to return false for this one if you check over here. Okay, so I hope that might be you are a little bit confusing this one. Don't worry, I will walk you through this problem, okay, step by step. All right, ladies and gentlemen, so let's just start solving this problem without any further ado. Okay, so my first job is to create a base condition. My base condition will say if my root is null, then I will simply return false for that. Okay, ladies and gentlemen, now what I will do, I will check. Okay, I will go deep inside in this tree and I will check if my tree has subroot present in this one or not. So for this one, I will make a function call. Let us say my function will say to check. This is my function, and it will check its root from subroot. Okay, so like this one, and if it's present, then I will return true for that, otherwise false. And finally I will return, what I will do, return, I will go for its left and right. I will go for my root tree left and right to check the subroot. So for this one I will simply say subroot root dot left subroot, just check it over there. Or it, as I told you, it might be present on the left or it present on the right. If it doesn't present anywhere, then we'll simply return false, because false or false means false, but true or false or true means true. So I hope so this operators, this condition operators. Okay, anyways, let me select it. Subtree. Now we will go for its right. A mistake. I don't know why I'm doing too much mistake over here. Ladies and gentlemen, so let me just make it a little bit side over here. Okay, here we go, ladies and gentlemen. Okay, so now what I will do, I will make a call to my that function, and I will say, okay, let me just make it boolean again. Yeah, boolean to check. And in this one, what we are storing the same thing, tree node root and tree node subroot. Alright, ladies and gentlemen, so now what I will do, I will just simply say, okay, do one thing. Let's just make one base condition over here as well. The base condition will say if my root is null, or let's say my subroot is null, then what we have to do, then just wait and see what I'm doing over here. If my root is null or my subroot is null, then what it means, we have to return false for that. So simply I will say, okay, return, just check again, return root is null and sub root is null. So what it means, like if any one of the condition will become false in this one, then you know true and false means false. So that's why I'm doing over here the same thing. I hope so, ladies and gentlemen, this thing is clear. Anyways, now what I will do, I will just simply say, okay, check if my root dot value is equals to my sub root dot value. Now you will say, okay, that's the only condition. Now what we have to do, we have to return true for this one, because you know I say like if my root dot value is equals to my sub root dot value, then it means like simply return true, as simple as that. But wait, I told you in this is the superb condition. In this one we will fail. Why? Because okay, these values are similar, these values are okay, these are okay, but this tree does not has any left leaf node, left leaf tree. So for this one it will gonna false, so it will come true, but the answer has to come false in this one. So for that one, ladies and gentlemen, I don't have to do this thing over here. So let me just erase all this shit from over here, and here we go. So what I will do, I will just simply say, okay, instead of putting true over here, I will just simply say return. Now check on its left and right completely. So that thing I will do over here. We need to check what my root dot left has to be similar with my sub root dot left, and similar thing with my right as well. So return to check. Let me just move this thing over here to check what my root dot right with my sub root dot right. I hope so, ladies and gentlemen, now this thing is clear, like what I'm doing. I hope so. Things are making some sense. Otherwise, if this does not satisfy, then simply return false. Then it will like we are not able to find the condition, and that's all the code is, ladies and gentlemen. So let me just give a quick run here to see any compilation error we are facing, and then I will take you up way back to our code and accepting variable. So here we go, ladies and gentlemen. If you see, so I already checked this condition. So you see this condition I have already put over here. So let me just check for this one as well. Like, do this one satisfying this condition? As subroot is similar, 412 is similar. Okay, so it's no worries about that. It has to come true for this one. And here we go, ladies and gentlemen. So it's accepting very well. Okay, so let me just talk back about our code, what we are doing over here. So first of all, I just create my base condition. This is my base condition, and over here I just check if my subroot is present in my root. If it is present, then return true. So for this check, I just simply make a call to another function which we are doing over here. And finally, what I see, go to its left first, then go to its right to find our subroot. That's what we are doing over here, ladies and gentlemen. And finally, in this function, I just come into this function, and in this function I will check if any one of them is null, then check if they both are null. If they both are null, then we will return true. If one of them has value, like let's say root has something or subroot has something, then we will return false for that one. Simple. And in this one, we are comparing their values. Let's say like we just found it. Now we have to compare their values as well. So that's what we are doing over here, ladies and gentlemen. And if let's say if the subroot is not present in our root, then we simply return false. If these all conditions are failing, then we simply return false for this. Alright, ladies and gentlemen, let me just finally submit this code to talk about its time complexity and space complexity. So let me just submit it, and here we go, ladies and gentlemen. And here we go, ladies and gentlemen. So it's accepting values going very okay. So the time complexity in this one we are dealing with is big of m into n. The time complexity in this one we are dealing with is big of m into n. Now you ask what is m and what is n. M is number of nodes in root, okay, and our n is number of nodes in subroot. That's all, ladies and gentlemen. Okay, this is our time complexity, and the space complexity is big O minimum of m comma n. Now you ask why minimum? Because like it will only give the minimum value. Like let's say the m has the minimum nodes, so the n has the minimum nodes. Which one has the minimum nodes, it will give the space complexity according to that. So ladies and gentlemen, I hope so this thing is clear, like how we are solving and performing this problem. So if you still have any doubt, ladies and gentlemen, just do let me know in the comment section. I will definitely want to reach to you. And thank you very much, ladies and gentlemen, for watching this video. I will see you in the next one. Till then, take care, bye bye, and I love you guys. Believe me, I love you. Take care, bye bye.
One thing, I don't know why, it doesn't even matter how hard you try. Keep